Good morning, everyone. Welcome to the STEM Digital School. This is grade 6 Natural Sciences and Technology. All right, so guys, today we will be revising or recapping what we did in class last week, because the numbers on Kahoot were not very desirable. So I just thought, guys, that we do these enrichment lessons that everyone can get to understand what we covered last week. Okay. So guys, just before we continue, all right, let's just go through the class rules together. All videos need to be off during the lessons. Then you guys are not supposed to use bad language. If you are chatting to each other, please do that in a respectful manner and only chat on content-specific information. So that would be information that we are dealing with in class, right? And if you are disruptive, you will be removed. Okay, so you can raise your hand, as said before, if you have any question or answer, or you can use the group chat to just to communicate your questions and answers. All right, cool. So another thing again, before we go on, guys, please raise your hands if you wrote the test. Please raise your hands if you wrote the test. If you did the informal assessment, can you please raise your hand for me? And please raise your hand if you did the informal assessment. All right, so I only see 4 hands which are up. Is that the number of us who are present today in class that did the assignment? Okay, 5, all right. Okay, so I'm just gonna repeat, please raise your hand if you wrote the assignment. Okay, I see 6 hands. All right, okay, 7. All right, okay, thank you guys. You can put your hands down. Okay, so if we have additional learners joining in throughout the session, then I will ask the question again. All right, so I'll ask the question again just before we end the lesson. All right, cool. Yes, okay. I think I also just received your assignment throughout the weekend. I'm not sure if it is you, but yeah. All right, cool, guys. Let's get into it. So we're starting off with electric circuits, right? So you guys know something, right, about electric circuits. We did a Kahoot on electric circuits. We did a breakdown, right? We looked at it deeply. So I'm just going to start off with a few questions with regards to electric circuits. All right, cool. First question, what is energy? So remember, you can raise your hand or you can type it in the group chat. What is energy? Okay, Moronga. Moronga. Just accept on your side for your mic to unmute. Ne? Okay, so Moronga, we can't get to unmute your mic. Okay, let's see a Sive. Oh, all right, cool, no problem. Sive?
It's the ability to do work.
All right, thank you very much, Sive, for that answer. Okay, do we have any hand which is up again? All right, cool. Kia?
Good morning, ma'am.
Good morning, how are you?
I'm fine, and how are you?
I am well, thank you.
Okay. Energy is the strength required for physical and mental activity.
Wow, okay. Energy is the strength required for mental and physical activity. All right. Okay, cool. Thank you very much, Kia.
Thank you, ma'am.
Awesome. Right, so I see in the group, Nduvo says the ability to do work, all right. Shakira says the strength required for physical and mental activity. Okay, guys, the different, okay, no, it's fine, never mind. Little Gusha says energy is a source of power, all right. No, Josie Lee, you're not late. All right, cool. All right, thank you very much for those beautiful answers. And remember, I think I did mention it to you guys that energy is the ability to do work. All right, so the different answers that I got was energy is a source of power. All right, and then we can also define power. Okay, and the strength required for physical and mental activity. So it gives us some sort of ability. All right. Okay, cool. So your guys' answers were not far off the mark. They actually are correct. Okay, cool. Next question. What is electricity? What is electricity? Yes, Kia?
Thank you, ma'am. Electricity is a current that is used to make appliances that need electric currents to work.
Okay, so electricity is current. That is, just repeat that for me.
That a current that is used to a current that is used to make electrical appliances work.
Okay, so it's a current that is used to make electrical appliances work. All right, beautiful. Thank you very much, Kia.
Thank you, ma'am.
Awesome. All right, Mashore.
Hello, ma'am.
Hi, how are you?
I'm fine, and you, ma'am?
I'm well, thanks.
So, ma'am, electricity is a type of energy that powers certain electronics and machinery to enable them to do work.
All right, so it is a type of energy that empowers machinery and other appliances for them to do work. All right, thank you very much, Mahlore, for that answer.
Thank you, ma'am.
Awesome. Piwa?
Ma'am, electricity is the flow of charge and is used to light up stuff like phones, tablets, laptops, computers, TVs, and other stuff that use electricity.
All right, beautiful. Thank you very much for also just adding those examples. Thank you, Piwa.
You're welcome, ma'am.
Awesome. All right, and last hand, Kamohelo. Kamo.
Ma'am,
Oh, sorry about that.
ma'am, electricity is a flow of electrical power or charge.
Okay, electricity is the flow of electrical power or charge. All right, beautiful. Okay, so let's go to the group chat. Shakira says a form of energy resulting from charged particles. I like the breakdown of that answer, Shakira. Ndova says the supply of electrical current to a building for heating, lighting, and powering appliances. Thank you very much for just giving also the functions or the output energy of electricity, then Nduvo. Then Snebile says electricity is a type of power we use to light up homes for electrical appliances and machinery. Beautiful. Okay. Okay, Leto, I see your hand.
Ma'am,
Yes.
ma'am, electricity is a source of power that flows through wires and comes to our homes.
Beautiful. So you even mentioned components that are used to bring through this type of energy, which is electricity. Thank you very much, Leto.
Thank you, ma'am.
Beautiful. All right. Cool. So my answer is that electricity is the flow of charge in a circuit. And you guys actually, you went an extra mile, right? And you explained in greater depth that electricity is a form of energy, and also hence we started with the first question where I asked you guys, what is energy? So you might have learned from your previous grades that electricity is also a form of energy. All right, so it gives us some sort of, or rather, it gives us useful output energy like the heating, the lighting, etc. Then Shakira also mentioned that it is charged particles. So this flow of charge, it is charged particles or electric current, as some of you guys might have mentioned. All right, so let's continue. I think I have another question. Okay, Piwa, just before we move on.
Sorry, ma'am, to disturb the lesson, but I just quickly wanted to ask for your email to send the test.
Okay, I'll put it in the group chat.
Okay, ma'am. Thank you, ma'am.
Okay, no problem. All right. So far I see we are all getting it. We're all on the same page, and that is beautiful to see. Next question: how do we construct a simple electric circuit? How would you construct a simple electric circuit? How? How would you construct a simple electric circuit? Yes, yeah, I got your test. Yeah, I got your test. Come, guys, raise your hands. You knew what electricity was. How? We were on a great flow. Oh. How do we construct a simple electric circuit? Okay, Triasha, I will hold on. Yes, yeah.
Thank you, ma'am. A way to construct a simple electric circuit is that you cut 15 centimeter lengths of wire, remove about 1 centimeter of plastic from each end of copper wire with the wire stripper or knife. Join one end of the piece on the wires to the positive terminal of the cell with tape. Attach the other piece of wire to the negative terminal of the cell with tape. Using tape, join the two free ends of wire to the bulb. Disconnect one of the wires from the cell. Connect one side of the switch to the disconnected wire. Connect the other side of the switch to the third 50 centimeter length of wire. Connect the other end of that wire to the bulb. Close the switch. Observe what happens to the bulb. Open the switch. Observe what happens to the bulb.
Wow. Okay. So that's why you guys took time. You were searching for it in the textbook.
Yes, ma'am.
Okay. Thank you very much for sharing, Kia. That was
Thank you, ma'am.
a beautiful answer there. Kia said, or even gave us examples of the lengths of the wire that will be used and how you should cut it and how you should attach it to both terminals of the battery. Okay. I saw another hand. Okay, but it's down now. Okay. Shakira. Okay. She says attach two wires to the ends of a battery and connect it to a light bulb. All right, short and sweet. Michael says electricity, okay. Electricity is a set of physical phenomena associated with the presence and motion of matter that has property of electric charge. Michael, what is a phenomena? Just enlighten us there. What is a phenomena? Electricity is related to magnetism, both being part of the phenomenon of electromagnetism. Wow, big words, Michael. So just explain to us what you mean by physical phenomena as well as phenomenon of electromagnetism. Now, Michael, just enlighten us there. Thank you very much. Okay, so guys, just as Kia mentioned and Shakira also mentioned in the group chat, What you need is a source of electrical energy, right? You need conducting material, and you also need a device that transfers energy for useful purpose, such as a light bulb, which would give us light. So you connect all these three things that I have just mentioned. Shakira said that have a light bulb, have wires, connect the wires to the battery, connect the other ends of the wires to the light bulb, right? So short and simple, we are that, or rather that is how we make a electric circuit, okay? Right, cool. Next question, what are electric components? What are electric components? And in terms of this question, you can give me examples, right? So you can give me examples of these electric components. Examples of electric circuit components, and you can also just explain to us what they are. Okay, Nomathemba.
Ma'am, it's a battery, wires, and a switch, and a light bulb.
Battery, wire, switch, and light bulb. All right, beautiful. Thank you, Nomathemba. Is that your name, Nomathemba?
Yes, ma'am.
All right, beautiful. Thank you. Okay, Kia.
Thank you, ma'am. The electric circuit components are a cell, switch, electric wire, and bulb.
All right, beautiful. Thank you very much, Kia, for that. Okay, so guys, Michael is helping you out if you guys don't understand his definition. Michael says the phenomena is an observable fact or event. So that might help, you know, for English. You can use those big words. Phenomena and is an observable fact or event. Right, cool. Let's go back to my question, which was what are electric circuit components? Nomathemba and Kia, they gave me answers. They mentioned wires, they mentioned batteries, they mentioned cells. Yeah. Nomathemba said battery, Kia said cells, we had electrical wire, we had light bulb. So guys, electric circuit components are components used in the construction of a circuit, okay? So these components are found in electrical circuits like conducting wires, batteries, switch, as well as a light bulb, all right? Okay. And so here we have an example of those electrical circuit components. We have our light bulb here, and we have our cell or our battery, and we also have the conducting wire. All right, batteries. So we're just gonna go into greater detail with batteries now. We're gonna look at different types of batteries. So let's just look at the information that we have with regards to batteries. Okay, so batteries come in all shapes and sizes. For some appliances, it is very important that the batteries are put correctly into a specific position, right? So that is in order to get the current to flow properly. And remember, we said that current moves from positive end to the negative end. Okay, so this is because the battery is used to get an electrical current or an electrical charge, as other textbooks may put it. And then in the appliance and in some appliances, the electrical current can only go in a specific direction through the appliance. And now we have, different batteries are gonna appear on screen, and you guys need to tell me what you think the battery is used for. So now the first battery is up. Where do you think this battery is used in or for? Okay, let's hear here.
Thank you, ma'am. The battery is used in a car.
In a car, so you think it's a car battery. All right, cool.
Yes,
Thank
ma'am.
you. Let's hear Triasha.
Ma'am, the energy box is used in cars, and it uses what they call it is, I think it's a gearbox.
Okay, so it's used in a gearbox in the car.
Yes.
All right, thank you very much, Triasha.
Welcome, ma'am.
Awesome. Okay, cool. So I see most of us in the group chat, Shakira Kamahelo, Josie Lee, Kia says it's a car or a motor, and that is correct. We have this, or rather, it is a car battery. Okay, and these batteries, where are they used, or what do you think they are used for? Okay, let's hear. Triasha?
Ma'am, those batteries, they are used for watches and what else? I think they are also used for some mouses that they use for computers.
Oh, okay. Wonderful. Thank you very much, Triasha. Okay, let's hear Nomathemba.
Ma'am, small toys.
Small toys. All right. Beautiful. Thank you very much, Nomathemba. Kikia? All right.
Thank you, ma'am. I've seen those kind of batteries in my mom's laser pen that she has. It's a pen that has a flashlight and also a laser. And then I've also seen that in watches and some mouses for laptops.
All right. Wonderful. Wonderful. Thank you. Then Leto. Leto Kuhle.
Ma'am, I've also seen those batteries. They are in my mom's car keys.
Oh, wonderful. All right. So thank you very much for sharing, Leto. Okay. So yes, guys, all the appliances that you guys have mentioned, I see remotes, toys, laser pens, and I've seen them in watches as well as toys, right? So yes, you are correct, guys. It is your watch battery or your toy battery. Some of you mentioned a mouse and laser pens and toys as well. All right, let's see here. All right, beautiful. Okay, let's see the next one. This battery. Where have you guys seen this battery? Or where do you think this battery is used in? Nomathemba?
Remote.
A remote. Okay. Thank you very much, Nomathemba. Mashori?
Yes. Ma'am, I've seen these types of batteries in lots of appliances that are either remote controlled or are remote themselves, like in RC car. I've also seen them like in one of our Xbox controllers.
Oh, all right. That's great. Okay, thank you very much, Mashori.
Thank you, ma'am.
Great. Leto? Leto Kuhle?
Ma'am, I've seen those batteries in a mouse.
A mouse. Okay.
Yes.
All right. Thank you. And then we have Kia.
Thank you, ma'am. I've seen those batteries in a laptop, in Xbox controllers. I've also seen it in I also see it in walkie-talkies that we use. And yes, ma'am, that's where I've seen them.
All right, beautiful. Okay, so I've seen these batteries being used in mostly remotes. Okay, so all the appliances that you guys have mentioned, they do indeed use these batteries. Also a torch, sorry, yeah, also a torch. They usually use these batteries, and most appliances which they make now, they basically use these 1.5V batteries. Okay, next picture we have. I don't know if you guys have seen this battery before, but okay. Wow, all right. Let's see, Nomathemba.
Phone.
A phone, okay. Wow, guys, do your phones have removable batteries? Okay, thank you very much, Nomathemba. Let's see, Piwa. Okay, Kamahelo, you are on?
Ma'am, I've seen that battery in my phone.
On your phone, all right, okay. Thank you very much. And who else do we have? Pure.
Ma'am, I've also seen a battery like that in a phone.
Okay, beautiful. Okay. I see you guys. So yes, indeed, this is a phone battery. Okay. So yeah, nowadays the phones that we have, or rather that they make, they don't have removable batteries. Okay, so in this next battery, have you guys ever seen this battery? And if you have, on which appliance was it used on? Okay, Nomatemba, I see your hand is up.
Ma'am, a small radio.
Small radio, okay, thank you very much. And then, let's see, come hello.
Ma'am, I think I saw that this battery in when I was in this competition Formula One, you use these batteries to charge our cars.
Oh, you use this type of battery to charge your car. How big was the car?
It was very small, ma'am.
Oh, is it like those
It was a
remote
child
cars?
competition.
Oh, okay. All right. All right. Thank you very much. And then Neto, let's hear.
Ma'am, I've seen those batteries in the fake toy walkie-talkies.
Okay, in the walkie-talkies. Okay, I've also seen these batteries in the walkie-talkie actually. Then we have Triasha. Where have you seen this battery used?
Ma'am, I've mostly seen these batteries on remote cars.
Remote cars, okay. Thank you
Yeah.
very much. And then what else do we have here?
Thank you, ma'am. I've seen those batteries in. I think they've also been in walkie-talkies and in toy battery cars.
Toy battery cars. All right. So thank you very
Yes,
much,
ma'am.
Kia. All right.
Thank
Awesome.
you, ma'am.
Cool. So Gerard says they have seen these batteries in a bass guitar, being used for a bass guitar. All right. So I've seen it in walkie-talkies, and you guys mentioned that they also used in the car, the remote cars, right? So what we can get, guys, from this exercise is that batteries come in different shapes and they come in different sizes. Okay, so they are made particularly for a specific appliance, right? You cannot use a phone battery to charge a torch. You cannot use a car battery for a watch. Neither can you use a watch battery for the car. It will not work. All right. And what we also notice about all these different types of batteries is that they all have that positive as well as a negative terminal. Okay, so all of them, no matter the size and no matter the shape, they all have that positive as well as negative terminal. If you can just look at the car battery, it has this terminal right here and that terminal right there. Even with the watch, the one side is a positive, the other side is a negative. With this torch battery, you might see, you might have seen that the one end has this bulging point, right? And the other end is just flat. And then on the phone battery, there's a positive as well as a negative end. And even in this walkie-talkie battery, there's a positive as well as a negative end. Okay, so if we just look at the second point again, it says that for some appliances, it is very important that the batteries are put correctly into a specific position. And we can see that here with the directions, that in this particular remote, it requires the positive end here and the negative end should be there. And then on the other side, there should be a negative and the positive. All right. Okay, Piwa.
Ma'am, may you please go to the previous slide so I can quickly write that down?
Okay, no problem. All right, guys, remember the rules. Remember the rules, please. Let's not fight, guys. It's Monday. It's Monday. And you guys still have so many classes to go to together. Don't do that. Okay, Piwa, you can just indicate for us when you're done, no? Okay, Mahlori?
Ma'am, I just wanted to confirm that we actually got our tests. We sent them over the weekend.
Oh, okay, you send your test through over the weekend.
Yes, ma'am, but we're not sure if they actually went through. So, ma'am, I just wanted to ask you if you got them.
Who was the sender?
It was our mother.
So it was not you alone. It was you and?
It was us, me, Piwa, and my younger brother, Pandile.
Okay, just send me your mother's name privately in the group chat. Okay.
Yes, ma'am.
All right, cool. Thank you very much, Mahlori. All right. Okay, so PY is done and we can move on. All right. Oh, sorry. So remember the difference between a cell and a battery, right? You said a cell is just one, and a battery, it is multiple cells together. And remember the positive and negative end. I think some of you guys got it incorrect on the Kahoot. The longest strand is the positive side. The shortest strand is the negative side, all right? Then in terms of electric charge, all matter, solid, liquid, gas is made up of very tiny particles. Some particles have negative charge and others have a positive charge. Charges attract or repel each other. Charges that are the same are called like charges, and like charges repel each other. Very important to note. I am going through this again because some of us got it incorrect during the Kahoot. Okay, like charges, they repel each other. If you have a positive and a positive, they repel. If you have a negative and a negative, they repel. All right. Then charges that are not the same are called unlike charges, and these charges attract each other. And here we have the summary. Okay. Unlike charges attract, like charges repel. All right. Okay, Mahlori, I see the email. I'll just check now. Okay, then we get to switches. So we went through switches. If there is a break or a gap in a circuit, the charge will not be able to flow. The charges will not be able to flow. And then the purpose of a switch in a circuit is to stop the flow of electric charge through the circuit. And then when the switch is off, the charges cannot flow, so the whole circuit is off, right? And when you close the circuit by switching, guys, videos. Also, guys, the chats have been closed now. If you do send a message on the chat, you can only send it to me or to the host, all right? So we'll just raise our hands if you guys have any questions or if I to ask for answers, right? So Tokello, you can also just type for me in the group chat your question because it looks like you do have a question there, right? Mashab, can I go back to the electric charges notes? All right. Mashab, I remember we did this last week. Okay, so you weren't in class last week, Monday. We did, yeah, we did go through this last week. So you can just check through in your notes or, all right, cool. Let me just go back. Or rather, let me wrap up switches. When you close a circuit by switching the switch on, it is like connecting two wires together so that charges can flow again. All right. So I'm just gonna go back to electric charge because Mashava asked that I go back. So Mashava, just indicate for me when you're done. Né? And guys, while Mashava is still busy, I'm going to make a request. Can we please raise our hands if we wrote the test? Because some of you were not in class or rather had not yet joined when I asked this question. Please raise your hand if you wrote the test. Please raise your hand if you wrote the test. If you raised your hand when I asked the question in the morning, please raise it again. Guys, please do keep your things, your hands up. Keep your hands up for me. If you did write the test, not if you send it to me. If you wrote the test, downloaded the test and wrote it, just raise your hand for me, please. Guys, keep your videos off. Thank you. All right, so I see 7 hands which are up. So it's 7 out of 21 students that wrote the test. Keep your hands up. Yeah, okay, Nomatemba, I saw yours. All right. Michael, you also just said that you didn't send it through. Kamahelo Moronga, I saw yours throughout the weekend. Mahlori. Guys, that's some of you guys, Leto, you saying yes? Are you saying yes? I wrote the test. Jared, I see you saying no. Are you saying no? I didn't write the test. Okay, I will repeat. Raise your hand. Don't use the yes and no part. Raise your hand if you wrote the test. If you wrote the test, raise your hand. All right, cool. Thank you very much, guys. Thank you. Mashaba, I believe you are done now. We can move on. So to those of you guys who wrote the test and haven't sent it to me, please do so as soon as possible so that, or rather Wednesday, we're gonna do the memo. All right, Wednesday, we're gonna start off with the memo and go through it. You guys can put your hands down. Yeah? Thank you very much. All right, so 5 minutes into, or rather 5 minutes left. Yeah, it seems like we'll continue with switches tomorrow. Okay, we'll continue with switches as well as light bulbs tomorrow. And guys, here is your homework. All right, homework. And I need you guys to share with us tomorrow in class, when was electricity discovered and by who Okay, who discovered electricity and when was it discovered? And then next question is, who invented the light bulb? And the third question is, who invented the battery and what was it used for? The first time it was invented, what was it used for? Okay. So I still see we have hands which are up. I don't know, do you guys have questions? Let me just hear here.
Ma'am, I wanted to say thank you for teaching us. God bless. Bye-bye.
Okay, yeah, but I haven't said bye. I'm giving you homework. Don't go.
Oh, okay. I'm not going, ma'am.
All right. God bless you too, though. And I love teaching
Thank you,
you
ma'am.
guys. Awesome. Okay, Mahlore?
Ma'am, I just wanted to quickly confirm that you did get the work, the
Okay.
test.
Your test, did you just send it again? Try sending it again.
No, ma'am.
Because I sent you a message saying that I don't see that email address in my inbox. Just send it again for me. Okay.
Okay, ma'am.
All right, cool. Just put also your name on there and the grade. All right.
Yes, ma'am.
Okay. Awesome. Cool. All right, guys, write down your homework, please. When was electricity discovered and by who? Next question is, who invented the light bulb? And the third question is, who invented the battery and what was the battery used for at that time when they invented this battery? Okay, so I'm going to give you guys a few minutes before we officially close off class. Okay, so if you do have any questions, you can raise your hand and ask me. So this is for tomorrow, all right? This questions are for tomorrow. Then Wednesday, we'll be looking at the memo for the assignment. Right, are we done? Can we move on? Can we use the yes, no button? Can write done or not in the group chat. All right, all right, all right. Oh, okay.
Hi, ma'am.
Hello, how are you?
I'm good, and you, ma'am?
I'm good, thanks. Can you please give me the pronunciation of your name?
Simran.
Simran. Okay. Hi, Simran.
Yes.
What's up?
Hi, ma'am. So, ma'am, I just joined the class today because we only got sent the link this weekend. So I don't know what test you're talking about.
Oh, okay. So last week we had a test on Wednesday. It was with regards to term 1 as well as term 2's work, right? Which is life and living as well as matter and materials. So if you have covered those contents or those topics, then you can also just go on the website, right? And on the website, go to the STEM Digital School and then these assessments. Then you can go to grade 6, natural sciences and technology, download the test, write, fill out the answers, and then you email it back to me. Right.
Okay, no problem. Thank you.
Awesome. Thank you, Simran.
Thank you, ma'am.
Cool. All right, guys, officially, thank you very much for joining in class. The textbooks that we used is the Via Africa Natural Sciences and Technology, as well as the Siavula textbook, which you can get on www.thunderboltkids.co.za. And if you do have any questions, you can email the school at stemdigitalschool@africateengeeks.co.za. And my email is just down there. That is where you guys send your tests. So guys, have a beautiful day and enjoy the rest of your classes. Goodbye, guys.